Hello and welcome to our webinar, Automated Gap and Flash Measurement together with Hexagon Nextsense. I also want to thanks Felix Müller from Hexagon Nextsense to join us and support us during this webinar.
Yeah, thank you very much for the invitation. Happy to be here.
And we will start with a pre-recorded session, which we did, Felix and me, by the end of last year. It's with a voiceover in English because we did the first webinar in German. And after the pre-recording, we are here and happy to give you a Q&A session. So if you have any questions after the pre-recorded session, there's plenty of time to discuss and talk about the flash and gap solution.
Yeah, if any questions come up during our recorded part, just type it into the chat. We will take care about that afterwards then.
Perfect. So let's start with the video. Just give me a second.
Hello everyone, and a very warm welcome to all our listeners and guests who are joining us today for this webinar presented by Nextsense and Eleven Dynamics. To my right, we have Felix Müller from Nextsense. Felix, if you would please take a moment to briefly introduce yourself.
Hi, I'm Felix at Nextsense. I'm responsible for sales, primarily focusing on the automotive sector. We're meeting here today to chat a bit about automation.
That's right. We've already successfully implemented our very own collaborative project, which you can see a little bit there on the screen, the AUDI Sport cell at Böllinger Höfe. And specifically, we have a comprehensive multi-sensor system installed there. So it's equipped on the one hand with a Leica 8960 and an AS1 Absolute scanner, but also with the CB20 Breeze from Nextsense. Felix, perhaps you could elaborate a little on your sensor technology and especially on the specific characteristics of the CB20 Breeze.
Yes, happy to do so. I'll provide a little more background. At Nextsense, we essentially develop two DMS systems. This means we produce profile measuring devices that are used in various industries. For one, we're very well known in the railway industry, where we simply perform wear and tear measurements, so we're more involved in maintenance. However, a substantial part of our clientele is also based in the automotive industry, and in that particular field, we are highly specialized in gap and flush measurements. Historically speaking, our origins lie more in the domain of manual systems, specifically handheld measuring systems. Currently, we are represented there with our C14 systems, which are simply in active use to measure specific profiles on a car. If we now take a look at the car, it's mostly the case that we simply record functional values, and in our particular instance, that means gap and flush measurements. Gap and flush measurement is crucial for the geometric integration of car exteriors. It's functional for one. Of course, hoods and doors must open and close, but it also plays a big aesthetic role. This means gaps must be parallel, not wedge-shaped. We've been on the market with our handheld measuring devices for quite some time. That means we offer a combination of a tablet and a sensor, allowing me to easily move around the manufacturing plant and take measurements on various vehicles. The main emphasis here tends to be on the auditing of entire vehicles and also on the precise measurement of individual parts, often utilizing cubing techniques, but it's equally very universally applicable in certain specific development areas within the stamping sector. Now, over the years, we have observed that the measurement technology we manufacture was primarily positioned within the quality assurance sector, but we have also been receiving an increasing number of inquiries for inline measurement applications. What inline means for us, especially in the automotive industry, is that we must actually measure directly on the production line, and for this, handheld devices are only suitable to a limited degree. For this reason, we have developed a hybrid solution, and this is the Calipri C15. It's still operated with a handheld measuring sensor, but it's fully integrated into the entire manufacturing ecosystem. This means that it's no longer just a tablet. Instead, we now have large screens, industrial PCs, and are truly connected to the line's PLC, which allows us to automate certain steps directly within the process. However, we still have a human influence, which measurement technology does remove. I know, San, I can explain later how we eliminate user impact there. But crucially, and this is very important for our collaboration, we still have the human factor and also a human cost factor. This means that when I measure a car at the measuring station, there are at least 2 employees who spend their entire day there, occupied solely with taking measurements. To now eliminate this requirement and completely automate the entire process, we have introduced our CT20 line to the market. These are 2 head sensors, meaning they consist of 2 triangulation units installed at a specific angle. These are then in turn installed on a robot, allowing us to fully automatically measure vehicles directly on the production line and sometimes even off the line, but our primary focus is truly on inline measurements. This whole system works in body-in-white construction. It also functions naturally in final assembly, and it also works for our customers, like in our project at Audi, even off the production line within this multi-sensor cell.
Exactly, that's where we come into play with automated systems. This means that our 11 Dynamics automation suite covers the complete Nextsense sensor range. So we can use the CB20 both with and without the Breeze function. Perhaps you could briefly explain the Breeze function, because I find it extremely exciting.
The thing is, if we take a moment to look historically, where did automation in gap and flush measurement actually begin? We've actually seen a lot of this for quite some time now. I'd say it started back in the late 80s that automated measurements were performed on the car body. This means we've installed a sensor, specifically a triangulation sensor, onto a robot, and that robot then performs measurements directly on the car body. What exactly makes the body-in-white stage so unique? During this phase, the car is always positioned on a specialized skid, and it's securely fixed within our measurement station throughout the entire process. This means the vehicle drives onto the skid, which is essentially a robust metal frame, ensuring the vehicle is supported at several specific points. The vehicle then enters our measurement station, is carefully lifted up, and then held firmly in a fixed position. This is, of course, quite advantageous for automation, because the car can repeatedly be positioned in exactly the same spot. So we bring the car in, we take measurements all around, collect our data, export it, then the car goes out and the next one comes in. That's one thing, we've got it fixed. And another thing is, in the body in white, we don't have any transparent components. Measuring transparent components using optical metrology is a relatively complex process. Essentially, what we're discussing here are significant difficulties stemming from reflection. This means the following. Let's look at triangulation. What do we do in triangulation? We take a laser of some kind with a certain wavelength and essentially shoot it onto our surface. Then with a camera, we can capture the laser's reflection. But if the laser isn't reflected by the surface, but instead penetrates it, it's naturally difficult for us because we have no reflection and thus nothing we can work with. And that just happens. Historically, a lot of work was done with red lasers. A red laser penetrates the surface, is refracted into different wavelengths within this transparent material. And consequently, I get many artifacts. I can't evaluate these, or rather other wavelengths are reflected back. The camera with the appropriate wavelength filter cannot record anything. We are therefore unable to perform any analysis. This means the system's availability decreases. But now we want to measure on the finished vehicle, just like at Audi. This means we have various surfaces that are simply difficult to measure. Headlights, taillights, glass, and all such things are simply transparent surfaces, which are also more or less transparent. So it depends on the material again, but they all have one thing in common. They are simply difficult to measure. Now, there are various approaches to making something like this measurable. We can either continuously reduce the laser's wavelength, meaning we move into a blue or even a UV range. However, this also presents certain disadvantages and doesn't quite correlate with our measurement technology, because we measure with 3 measurement lines, not just a single one. We don't have a laser that's capable of doing that for us. So we're taking a slightly different approach, and that's what we refer to as Calipri technology. Calipri is the exhalation of a layer of water, a layer of condensation on the transparent component. I can always demonstrate this well when I have the glasses here. I'll just breathe on them once. The glasses will fog up briefly, just for a moment, and then our transparent measuring surface becomes visible. This is exactly what was done in quality assurance before with scan spray or various coverings. The same principle applies here. In our system, what we do is take a very small quantity of distilled water. This water is then blown by a heating coil onto our surface, where it condenses and effectively renders the surface opaque for a specific period of time. We can then take measurements on this surface, on this specially prepared surface, but the condensate disappears again. Why do we use distilled water? We simply want no residues. This means our vehicle is not manipulated. However, we are able to measure any surface there. And with this, it is now also possible in the final assembly or even in specialized stations, such as an audit station that we have now set up together with Audi to truly measure all surfaces to ensure very high system availability for the system and thereby provide our customers with truly important data regarding a specific component of the vehicle.
So as I've already mentioned, that's the really great thing about it. You brought up the key term, you said reproducible data. The human factor, so to speak, as soon as the process becomes automated, is completely removed from the equation. And with that, of course, you achieve a much higher level of process reliability. I just want to jump in quickly about you driving into the measuring station in the skid. Using our AUDI software, we can measure directly on the conveyor. That means if we know the conveyor speed and it remains constant, we can program the positions accordingly so that the moving vehicle can be measured for gap and flush while it is in motion.
Precisely. In some instances, an additional add-on is required for this, which we, of course, also make available. We possess a comprehensive portfolio for gap and flush measurement, truly ranging from handheld measuring devices all the way to fully automated cells. Especially with full automation in the final assembly area, in the actual assembly process, that is naturally quite complicated. As you've already mentioned, we're no longer on a skid, we're no longer in a fixed station or a fixed measurement environment, but the vehicle is actually moving on a conveyor belt. Now, it's naturally quite complicated for us, but for one thing, we need to, or rather, we collectively need to move the robot in perfect synchronization with the conveyor belt, specifically to accurately capture the vehicle as it's moving. Furthermore, it's also the case that the vehicle itself is subject to various influences. For example, the vehicle's height can vary significantly depending on factors like the specific wheel-tire combination, the equipment, and what type of suspension is installed. Has the suspension already settled and things like that? This simply means that you might also have height differences, but the vehicle can also be tilted. It can be tilted forwards, tilted sideways, or tilted diagonally. In addition, the conveyor speed is not perfectly stable due to the high load on the conveyor. A pulling or accordion-like effect occurs, particularly during startup. All of this information needs to be captured. For this purpose, we offer our BPOS solution. It's a system featuring 2 stereo cameras positioned above the conveyor belt, which primarily detects the vehicle's precise position, its various tilt angles, and also its rotation. Once the left, right, and vertical shifts are detected, it can practically calculate this. So we then record a point cloud, and this point cloud is matched to the cut. We then see, okay, where exactly are these shifts? That's converted into the robot offset and sent directly to the robot. We have already integrated this, which allows us to truly measure on a moving conveyor belt. This means we've effectively overcome 2 key challenges. First, that we are no longer restricted to a fixed position. And second, our capability to handle transparent surfaces. As a result, we can consistently capture stable measurement values with very high system availability.
It really is. It's truly a lot of fun to see the system live, I must say. I've had that luck a few times at Audi.
Very impressive.
At Audi, we're in a relatively stable setup, but even in such a situation, BPOS can be used to easily determine where the vehicle is positioned. So even if the position is semi-fixed, BPOS allows us to check where the vehicle is parked, apply the corresponding robot offset, and then start the measurement.
Absolutely. For anyone who might be interested, you can actually watch the video case study about this entire AUDI Sport SIL on our 11 Dynamics YouTube channel. From my perspective, it's very much worth seeing, highly informative and quite interesting. Now, a little bit of an outlook. We currently have quite a few projects we're collaborating on, so perhaps you could share a bit about where your journey is taking you, where your development is headed, and what your next key milestones are.
Well, we're seeing a global push towards automation, and that naturally doesn't bypass us. Of course, historically, as I've mentioned, we come from manual measurement systems and still have a very large global footprint where manual measuring devices are in use. But we've been seeing over the last few years that all the measurement processes are moving out of the dedicated measuring room and are being integrated directly into the production line. Quality assurance has simply always been considered a cost center, and naturally there are continuous efforts to streamline production, to reduce overall costs, and there are, of course, significant challenges, particularly here in Europe, where qualified measurement technicians are simply no longer as readily available. Even if I wanted to, I couldn't have that many measurement technicians standing in the line all the time, taking measurements constantly and then evaluating all the results accordingly. That's why we're seeing a lot of work being done on inline measurement technology, both in the body shop and in final assembly. I believe we're increasingly moving towards automation, and we'll also join you in that automation journey.
For us, the situation is quite straightforward. We are manufacturers of measuring instruments, so our primary point of contact with the customer is therefore within the automation at the robot flange. Our primary focus is on precise measurement and on the thorough evaluation of data based on specific customer requirements. We also ensure that our systems maintain high availability, possessing a high degree of absolute accuracy and demonstrating excellent repeatability in their operations. Ultimately, we guarantee that the system runs securely and does not interfere with your production process. What we truly need, however, to deliver a truly functional system to our clients is precisely a company just like yours that can help us with the integration process and take over the entire automation component and also handle all the robotics involved. This means for us, we'll continue to have a focus on automation,
because we clearly see the future of the automotive industry lying in a higher degree of automation, if not indeed reaching full automation when we look very far into the future. And in that area as well, we will continue to position our measurement technology.
Quite often with our customers, we naturally try to pass on our complete ecosystem to them. That simply has many advantages. For example, if I see, okay, I have a measuring station. In that measuring station, I can now check if my vehicle is okay or not okay.
Okay vehicles, obviously, will naturally continue to operate in the production process.
But what do I do with the not okay vehicle? Well, these must be corrected, and that's exactly what we do. And we say, okay, we take the vehicle, we drive it to an off-track area, or into a specific zone where I can correct the not okay vehicles, readjust them, but then I also have to measure over it again just to ensure that the repair was successful. We will continue to offer this with CB20 solutions, and in some cases, C15 solutions, thereby ensuring that truly every vehicle that rolls off our production line meets all of my specifications. Looking even further ahead, we naturally also want to make sure that the entire production process is documented somewhere and that we are aware of our production statistics and that we ensure we manage communication effectively right from the raw construction. From the coding process to the paint shop, all the way to the finished vehicle, we must be able to document and verify. So when we go to a customer and we are currently working on exactly these types of customer projects, we examine, okay, what does the vehicle look like in its raw state? Is the vehicle's body in white acceptable? And what impact do the settings and adjustments made in the body in white stage then have on my vehicle during final assembly? This means if I deliver an acceptable vehicle from the body in white, will the final product still be okay?
That means in the production process, there are naturally various influences.
If we just look at the doors, for instance, doors are installed in the body in white with the set kick, meaning the door is installed much higher than its final position. So the rear corner is slightly elevated. This is simply because we still install a lot of technology into the door. A glass goes in there, a window regulator, a sound system, and a door panel. The entire assembly naturally pulls the door downwards, and we must adjust these values accordingly so that the vehicle, when it finally reaches the customer, and that's the most crucial part, how the vehicle looks, ultimately functions correctly, everything closes properly, and it looks decent. We can only guarantee this if we make these adjustments during the body in white stage. And this communication, of course, must then be ensured. we can work together to ensure or to create results that are correlation-free for our customers. This means that if we deploy our system, regardless of its underlying basis, in both the body in white stage and the final assembly, we'll know we're using the same measurement technology.
Thanks to ADAS, we always have a repeatable position on the vehicle. And we also use the same evaluation strategy. So our measurement plans are precisely the same ones we use in body in white. And they're naturally also applied in final assembly, meaning the exact same measurement direction.
Here again, we scan very deeply into the gap. We can capture the complete gap contour, and we can do this without mathematical extrapolation or anything similar. This ensures that our absolutely precise measurements in the body in white are comparably correlation-free to the measurements taken in final assembly.
That's the beauty of it. I generate truly process-reliable data, which means I can, as you so nicely explained earlier, we can perfectly adjust our parameters based on continuous measurements so that within the robot, the gap and flushness are already preset to such an extent that theoretically during the final assembly process, there's practically no more scrap or waste. That ultimately is the main objective.
Yes, the objective is truly to ensure our output is entirely free of defects or the need for any rework. We typically don't produce any scrap.
Exactly, but that rework in final assembly is practically almost zero, meaning that essentially only the green ASIS condition is documented.
And I can, of course, then also conduct process control. So I can monitor if a tool is wearing out somewhere or if my supplier quality is acceptable. So I can check, okay, if my process deviates somewhere, then I can see, okay, which specific process step it's in, and then I can investigate, okay, do I need to adjust something? Is a tool worn out? Is it the component itself? And by doing so, I can ensure that my process is simply stable and free from any rework.
Exactly, especially intervening early in the process, because it's naturally in final assembly. If I notice that you have a problem, it's much, much worse.
It is correctable, but it always involves a lot of effort.
Right, so the amount of effort required is, of course, if I properly manage the process, clearly identify my variations, and then, so to speak, take corrective action early, it will always be the significantly lesser effort.
Yes, and not only what I measure, I truly know in the end. Of course, you can choose to skip some measurement points. However, that is always connected with a certain risk. So, for example, we had a client who completely omitted the glass measurement process. This was because their existing measurement technology simply wasn't functioning correctly when applied to that specific type of surface. And this oversight directly led to a significant issue. The seal of a headliner cover became improperly caught or pinched. Consequently, a large number of their vehicles experienced severe water ingress, which ultimately led to the recall of the vehicles. And that's naturally the worst thing that can happen for the OEM. It also, it somewhat damages the brand's image.
Exactly. It's also damage to their reputation that no one wants, so to speak.
And it's, of course, a huge effort.
Definitely. As I mentioned before, just to clarify for your understanding, so we currently have a project that we are working on together where we essentially check and measure the gap and flushness at two different points during the body in white stage. This means first, before the vehicle actually enters the station where the gap and flushness are then adjusted. This means that, first of all, it is determined precisely where and how adjustments need to be made. And then when the vehicle essentially leaves the station, a second measurement is taken to verify that the settings on the one hand have indeed been carried out and also that they have brought about the corresponding and intended success.
Exactly. In the first step, we'll first check what the current state is. They then move on to the appropriate settings, and then right at the very end, they check it once more as a quality gate, meaning a final quality check before it reaches the customer, to ensure that all vehicles are in perfect order, ready for delivery.
All right, that's perfect. That's great. I think we've now more or less covered the main points of everything. So thank you, Felix, for your very detailed explanations. Following our webinar now, there's essentially a Q&A session. We are both available. If you have any questions, please don't hesitate to contact us at any time. Even afterwards, if not during the Q&A, should any uncertainties or further questions arise, please feel free to reach out. We'll also provide an email that will be sent out to everyone with all of our contact details. I'd like to express my thanks to you, Felix. Thank you very much for your time. I wish everyone a wonderful day, and I'll see you all later.
Welcome back and thank you for your attention. Checking the chat. Okay.
Okay, maybe one quick question. So
Yes.
We've got a question. We don't need a UV sensor. That's correct. That's correct. So when we're speaking of the wavelengths of the laser, or when we're speaking of transparency measurements, we always speak about wavelengths of the laser. That's correct. So the shorter the wavelengths of the laser is, so going from red to blue to ultimately in UV range, you see there's less and less penetration of the surface. Of course, the camera needs to see something, and that's what we already mentioned. So the camera needs a reflection. If the laser penetrates the surface, the laser could be refracted into different wavelengths, and then the camera won't see anything. So if we now use the vapor to basically coat our transparent surface, it's completely correct. We don't need a UV sensor, and there are many advantages coming from that. So basically, our sensors don't produce a lot of heat. They don't need a lot of power. They're not potentially dangerous to the eye, such as UV is. But ultimately, for us, it comes down to one key factor, and this is accuracy. The picture quality of our lasers is higher than whatever we got from the typical UV sensor that can be found on the market. So that's why we're going that way. We're going the way of Calipri Breeze, using a longer wavelength, because we don't have to go as short as UV. But in fact, we're using a 550 nanometer laser and a 505 nanometer laser in our bulk triangulation units.
Thanks, Felix.
Yeah, you're welcome.
Inside the Q&A tab, I don't know, Stefan
Yep.
and Felix.
I just opened it
Sorry.
up. So, no problem. So, Pavan, your question: do we need any calibration to set up VPOS and robot in the same coordinate system? Well, yes and no. The system itself is calibrated once. So it is set up based on your coordinate 0 point. So that depends a bit on the robot that you're using, because for some robot types it's different than it is for others. However, once the system is set up, you don't need a calibration anymore. So it's calibrated once within the commissioning, and then it doesn't need to be recalibrated. Of course, we need to take care that there's no one crashing into the cameras or something like that. But I think that's fully clear. But once the system is set, there's no need for recalibration. Between VPOS, the robot, and Calipri system, there is an internal PLC. Between Calipri and the robot, there are a couple of PLC protocols that we are supporting, which is Ethernet IP, for example, or Profinet. Anyway, I think with EDAS, Stefan, please elaborate on that. There are more protocols that are supported as well, right?
Yes, so it depends a bit on which protocol you want to use. There are certain type of protocols we can use. It's up, let's say, we are quite open. We can always work as a slave or as a master. So in this case, Miguel, I think if you reach out directly to me, which type you want to connect, so we can support you in this case.
Yeah, connection between 11 Dynamics software and CIS software, I think it's fairly simple. Basically, you teach the robot what to do. We use our part of the software for the evaluation part, and everything that's basically robot control is done over either software.
Yeah.
So I think now we're good, and now we should have covered it all. Just going through the tabs here, but yeah, it seems like everything is already answered. Yeah, guys, again, thank you very much. Thank you for your time. If there are still any open questions, let us know. Give us a call. We're happy to elaborate on everything.
Also, thank you from my side, and have a nice afternoon, nice evening. Thank you. Bye.
Thank you. Bye-bye.